I would like to welcome you all to this session. We have simultaneous interpretation in this session. Let me introduce myself. My name is Cihan SAHIN. I am an architect. I am the owner of my company. I worked in the Meteorological Directorate General of Meteorological Unit as an architect. Let me introduce Zeynep AKKAN. She's from the United States. She's a panelist, and she will talk about the climate change and its impact in the building industry. And we have Cihan SAHIN. He's from the United Kingdom, and he will talk about numerical weather forecast, data access, and processing. And the last panelist will be Dr. Levent YALCIN. He is from Turkey, Ankara, and he will talk about the relationship between meteorology and climate from construction to operation of zero energy buildings. So if you want, let me give floor to Zeynep AKKAN. Yes, the floor is yours. Thank you, dear moderator. Let me share my screen. Good evening, everyone. My name is Zeynep AKKAN. I am the project leader of the Volunteer Climate Reality. And I will talk about climate change and its solutions. Yes, now the slide works. Can you see my screen? Yes, this photo was taken in 1972 as part of the last journey of the Apollo, and it is called as Blue Marble. And it is said that it is the most published picture of the world. Climate change has three questions. Should we change? Can we change? Will we change? The first question, should we change? When we look at this horizon, we see the sky is infinite. However, there is a thin atmosphere layer that covers the world. It is a problem because sun rays reach our world passing through this thin layer, and some parts of this energy is consumed by the world and some parts is sent back to the space. It is something good because some parts of these sun rays is stored in this atmosphere, which maintains the suitable temperature for the world. However, we disseminate, discharge CO2, and some other destructive gas, which causes the thickness, which grows the thickness of the ozone layer, and it is problematic. And every day we produce 162 million tons. That means 6,000 atom bombs are used every day. It is so this is why these greenhouse gases are so distracting. What are the sources of these greenhouse gases? I will talk about the most problematic one later, but we have transport and also having permafrost, coal mining, and also methane gas from the industrial processes. There are some other issues, but the main problematic source is the use of fossil oil. As you see, since the Second World War, there has been an increase at an immense level since the Second World War, the use of fossil oils and the consumption. As we see, there is this global warming. In fact, there are 20 years, and the 19 hottest years were recorded in last 20 years, and 7 years of them were recorded during the last 7 years. And we also see its impact also in our country, and we have recorded 49.1 Celsius degree. It is unbelievable. It is the first time that we have recorded. In fact, the Meteorological Institute says there is this temperature records in Çanakkale, Kars, Elazığ, etc. In 2020, it was the hottest year in Europe, and it was hotter than 2019. In June 2020, the temperature became 38 Celsius degree in Siberia, which was not a usual temperature, and it was the hottest temperature in that area. Considering that 71% of the world is composed of oceans, this extra heat goes to the oceans, and 93% of this heat goes to the oceans. Of course, it increases the temperature in oceans, and when you learn that there was a new record in 2020, it is not surprising to you. So when there is an increase in temperature, oceans evaporates, and then it breaks the hydrologic circle because there is evaporation, there is raining, and then it returns to lands in the form of rains. And as a result of this, we see that the typhoons or the storms include more water, and in Philippines, thousands of people lost their lives. And we see that there is this global raining, abnormal activities of global raining, and it is much worse than last decades. In English, there is this term, these raining bombs, and it rains cats and dogs and downpour. It is from California, and also it floods affect our country. A few months ago, Artvin was hit by this flood. 6 people lost their lives. Many people couldn't leave their house. They were locked down at home. And we have similar cases in different parts of the world. It is from Australia. And we see that the level of rainwater reaches 1 meter. And the more evaporation from the ocean also causes dehumidification from the soils that leads to the aridness of the soils, and it was problematic. And it is from Brazil. Brazil suffers from the drought, the worst one in the century during the last 100 years period. And there is fresh water problem almost every day in Brazil. And our country is not excluded from all these problems. We see these type of problems in our country as well. As a result of these extreme hot temperatures, we see that these over temperatures and it causes certain problems, and it was problematic last year, but in California this year was worse. In fact, in the western part of the whole North America was problematic. In Australia in early 2020 there was a big bushfire, you may remember that one, and it caused a big destruction. 30 people lost their lives and about 1 million animals lost their lives. It was a tragedy. Of course, a few months ago in Marmaris, there was another bushfire. It was a big one. And there were 259 bushfires in 42 provinces in 2 weeks' time, and about 20 people lost their lives, and it was a big disaster. These extraordinary air disasters are increasing in all over the world. Extraordinary climate disasters, and as a result of the increase in temperature in Greenland, these glaciers are also melting, and in 2013 glaciers were totally melt. As you see, it has been accelerated. In fact, it is 4 times more than the calculations. So what we see that in addition to glaciers, the permanent ice layers are being melted, and it is important, and the ice loss per year in billion metric tons in Antarctica. And of course, what does it mean? What will be the impact of this ice loss? That means the level of water will increase, and the cities which are close to the seas might be lost. And you see the list according to population, but according to the properties based risk map, we see too many companies, but we do not have it. This list doesn't have European countries, but when we look at the European list, we see that 2 out of 3 most problematic cities are from Turkey. These cities are as follows: Istanbul and Izmir, and there will be 230 million US dollars damage if there is no control over the temperature. It is from Miami, and it's an octopus. So in Florida, we have these sunlights, and there is wind and tides. As a result, there is this flood. We have seen New York in that list, which is under the threat of this 30 billion US dollars, is under at risk of material loss if there is no control over the climate and temperature. Of course, countries that are island countries like Kiribati, when it was underwater, Kiribati is the first country that bought lands from other countries so as to transfer its citizens to the new lands. It is, of course, important for the national defense, and because the climate change will cause problems in terms of access to water, food, pandemics, and also refugees, and also there will be disputes over access to all these resources. And of course, it is also a health problem because of the temperature, because of the over temperature, our health will suffer from certain diseases, and it's a threat to our health. As a result of the climate change, people try to move to new places which were not settled in the past, and we see that there are new viruses which causes 5 to 7 pandemics or 5 to 7 endemics, and it is mainly from the zoonotic. That means these diseases are people are infected from animals, as in the case of the COVID-19 pandemic. And we also see that tropic diseases are disseminated because this temperature is spread over other areas, and the area of the endemic diseases become more problematic and pose certain threats. In this period, there is a risk of losing all species, all terrestrial species, 50% of the terrestrial diseases, of course, and the cost of carbon is so high that it affects the economy. It is the threat number one. So if this is the case, the answer to the question, should we change, is yes. And the second question is, can we change? Let's look at this question. We have solutions in our hands. For example, green energy. There is a growing green energy. In 2000, it was estimated that the wind turbines energy would reach 30 gigawatts capacity, but in 2020, the total capacity became 24 times more. And we see the increase in the capacity of wind energy. There is a similar picture. There is a similar situation in the case of solar energy, because it was estimated that there would be an increase about 1 gigawatt before 2020. And in 10, it was 7 times more, but 2020, it is 132 times more. It is quite optimistic and positive development. And we see the installations of the global solar energy and green energy issues. And as in the case of computer chips, the cost decreased, because in the past it was 79.40 US dollars per watt. Now it is 0.20 cent per watt. And thanks to the low investment cost, these equipments became accessible for underdeveloped countries as well. And it's an example from Chile. There has been a tremendous increase in solar panels. What we see that it is the amount of current projects that are under construction, and it will not, of course, not only meet the needs of Chile, it will also enable the Chilean government or Chilean companies to export this energy. And the good news is that solar energy is infinite, because the solar energy that reaches from the sun in an hour is equal to the consumption for a long period. Of course, it leads us to the question of store. How should we store it? But there will be an increase in this store because the global cumulative energy storage capacity is increasing, but we need more. And it is same for the automobile manufacturers. And as you see, these are the brands, and our country is also in the field of electricity manufacturing car with electricity-based system. Another issue is in this panel and in this conference, these energy efficiency building markets. We also see that it is also growing, and it will reach $1 trillion in the market. That means better windows, better glasses, and better lighting, and so that these buildings will be more efficient and will be zero energy buildings. As you see, commercial buildings are also renovating their houses for building and energy efficiency, and it will reach about $1 trillion, which is also promising. LED lights in 2025, it will reach 95% in the total market. And also we see, as a result of solar markets, the cost decreases. The curve shows the decrease. It was $160. Now it is less than $10. So the question of can we change is yes. The most important question is, will we change? As we all know, in 2015 there is this Paris Agreement, and all nations committed that they will work together to reduce the green gas emissions by 2050. And Turkey is one of the countries that signed, but Turkey was one of the countries that has not ratified that agreement by the assembly. But we just recently heard that this agreement would be submitted to the parliament and it would be ratified by the parliament. It's very promising. And Donald Trump, the former US president, withdrew from the Paris Agreement, but as following the election of Joe Biden, the US rejoined the Paris Agreement. It is very important, and the US is making investments in this issue. Turkey is making investment in this issue as well. It is important because conventional energy shareholders became bad investment tools. Now people are making investment in clean energy companies. And more than 300 global companies declared that they would use renewable energy in all their activities. And last year there were 200 companies. Now it became 300, and there are companies also from Turkey. In addition to the companies, individuals also and citizens also demand change from their governments. And this photo is from 2017, and more than 400,000 people marched at that time. And Climate Action Week is from Tennessee in 2019. On the same day, there were climate actions in Turkey and in different parts of the world. It is from Antalya, but there were actions from Ankara, from Karaköy, and different parts of the country. And it is from last year, from Bodrum on 20 September of 2020. And we have young people, young activists who are fully aware of the climate issues. And he is a climate activist, and he was awarded the Global Youth Award given by the World Nature and Protection Foundation. So, to conclude, in order to protect the future generations, our communities, and our world, I kindly ask you to join those who make their voice heard. Vote for this and make your choice, because defend what you know, what is true and what is right, because the world depends on you. Before I give the floor back to Cenk Bey, I would like to remind one point. There will be yes before the final no, and yes depends, the whole world depends on this yes. We are about to make a big change. We are at the edge of this big change, and green choices become a lifestyle. Sustainable techniques become standards in many industries, and zero energy buildings are a big part of this solution. And hope that the global warming will end, and they play an important role in our combat against the global warming. Thanks a lot for your informative presentation. Now I would like to give floor to Cihan Bey. Hello. Yes, I can hear you. Shall I begin? Yes, please. Yes, please.
Cihan Bey is preparing his presentation. He's going to talk about digital meteorologic subjects. And Cihan Bey received, he studies undergraduate studies at Hacettepe University, nuclear energy, and he had his master's degree in Reading University in computer sciences. And between 1997 and 1999, he worked as in meteorological meteorology, and Cihan Bey is working as an analyst since then. Cihan Bey, the floor is yours. Thank you, Cenk Bey. Thank you. I think you can hear me well. There is no problem with that. I will go to the previous slide. Can you see the slide? Yes. It was frozen in me. Cenk Bey, thank you very much once again. My presentation is about meteorological data, how the data are produced, or how to access this data, and what you can do to access this data. This is my area of expertise, and I'd like to give you information in this. Zeynep Hanım's presentation has been very informative, especially climate change, that she made a good situation analysis, and she discussed what can be done for the solution. In my presentation will be a bit more technical, and it's about the data we have. How can we use this data? I'd like to give you information about this. It's about the meteorological relation with the climate change, and then ECMWF, the institution that I'm working for. So this is one of the data producing centers. And then I'll talk about the relationship with the meteorology and climate, and how they are produced, and how we can access to this data, especially the Copernicus program. It is the European Union established program. I'll give you information about the Copernicus program, and it's about the and access to data. When we say the climate change, as Zeynep Hanım pointed out, summarized very well. And with the one slide, I'll talk about this. This is a very important subject because, as you know, the climate is changing, and there are many data regarding that. And one of the factors is the greenhouse gases. In global level, in order to decrease that, there needs to be something done, and because we will go in a way which there is no turn back of this. The data may not be there. IPCC International Panel for Climate Change makes international relations, and also, as seen in the report, if nothing is done until the end of this year, the climate change will be 4 degrees. And here, this shows the current situation. For example, in 1995, we can say that when we look at the baseline, what is the current situation? There is no thing in that. However, after the 70s, there's a huge increase. And in the graphic, it is about the natural factors, as we can see, because these are the factors there. This is the result of that. It is the greenhouse gas and of this, and globally speaking, temperature increase is more than once as the degrees. When we look at this, of course, it is not my area, but I made the research. It's not my area because here the emissions through that, and regarding that, the total greenhouse gases is 34%. So the importance of the conference that you're holding, it can be unfolded here, because there are emissions from the buildings, and it's about heating, or also the people there, and here the definitions with the data actually covered 40% of this, and it's a huge number, I believe. In order to achieve the figures, we have to have the zero energy buildings, why it is important. So in order to achieve this, the most important thing is about the energy and sustainable energy in order to achieve this. And of course, it's the energies that buildings need to develop the energies that they want, and it's about the renewable energy resources. And regarding that, when we look at meteorological data, the daily operational activities, the daily heat and others, could be hourly and could be daily, and in operational terms, it provides the duration of this. Why is it important? There are long-term strategies, the data, and there could be some long-term strategies. And of course, that is important in that when we say meteorological data, there are two factors. One is the activities. There are meteorological gases, and also where do we have the data? There are many weeks about this, and there is the air projection center, weather forecast center, and Turkey is a part of this, and there is a certain data about this, and also it uses the data there in as the meteorological center, and as we call it BCMWF, and the data computers can be there. And what does ECMWF is doing? This is a center, and we can say that there is at 724. It's an operationally global. In global scale, it makes it a numerical weather forecast. These could be monthly and others. And the operational data, there are other data. There is this information, and ECMWF is there in order to have the data, and it is the largest meteorological data, and Turkey is part of that institution. The meteorology and the climate has certain things. When we say meteorology, or when we say meteorological weather forecast, it is about the changes there. And when there are the meteorological ones, and it is a certain data set, but there is a projection there, and the energy use and the systems design for all these. You can look at it's all needed for increasing the efficiency. And here in this graphic, we can see is socioeconomically, we see the European World Meteorology Institution is having this. It is a construction and meteorological and atmospheric data, and there is a 1 billion data, and it's about the water and others. the meteorological data, how it is there. In order to have this, we need to look at we need to understand how the data is there. It's a simulation. It is working in super controllers. But in order to simulate a system, you need to have a certain system where the simulation will start. And we say that this is the initial, it's called as initial condition. And the initial condition, the data should be collected momentarily in everywhere. It is about the ones. What are the meteorological parameters? We have to look at this. It is the process of collection of data. So all the meteorological person and we can say that it is the data set is there, and there are different sectors. There are satellites, and also, for example, there are the observation stations working with the meteorologies. All the data to be collected. It is the ECMWF, and it's the data assimilation system is there. It makes the data uniform because the data most in this and there could be more data there. And here, for this is called as data assimilation, and the model is there. The simulation is there, and of course, it takes a long time. There could be rain and others, and in different styles. After the model is there, there could be 3 days, hours, daily. These are the parameters. When we say meteorology or when we say meteorological model, it is composed of that. It is done twice a year, twice a day, I'm sorry. And Cihan Bey, sorry, you have lost 5 minutes. In order for this process to be successful, the initial conditions should be defined very well, and the simulation should be there. Of course, these conditions, the simulation, even if you have a good simulation, the data will be bad, and therefore there is an ensemble system is there, and there are different conditions are studied, and also the statistical data is taken. So the meteorological data production is important, and of course it takes a long time. And the meteorological data is from the grid point, and the data is called as resolution. 9 kilometer, for example, ECMWF model, and there are regional models. The resolutions are very high. They could be 1 or 3 kilometers, and the data there can be used for the design work. And this is the resolution to be used. What is the data access? So with ECMWF, most of the data are paid, but they will be at the same time be free of charge. It is digital data, and you can use this. So the ECMWF is the data is for everyone. You can see that. And except for this, for the global numerical parts, some of them is the European American Center, and you can have access to that, and you can use all the data. And there are other data that the climate data is produced in the same way. However, there is a reverse chronology the simulation because it isn't a uniform data and it is not there. So the same system is used. So it's a meteorological model and we use it in a reverse way. And there's a data set. We are we say that there's a heating compared to 1965, 1950 or 1960, and we can use this data, and we can say that it is called era. It is called as era data. When you look at this, you can look all this, and this is with there's a program called Copernicus, and within this, it can be used free of charge. What is the Copernicus program? This is based on satellite observation. It is for environmental information and monitoring program. It's a huge budget program. And there are these systems, and there is atmospherical monitoring. And if we look at this, and this is the other data. And for monitoring the data, also managing the situation. There could be a flooding event, or there could be other fire outbreaks in the forest. They are all looked at, and there are different 6 programs. And the climate data can be taken in Copernicus program, and you can look at this, and there are climate bulletin published in every month, and with the different centers, they can use the centers. And when we say there is a CDS system, and when you enter into this system, there could be 3 hours, 6 hours, monthly, annually. You can say this. So if you are going to make an activity in this, if you're going to make a commercial activity, the Copernicus system, you can enter into this system, and likewise it's possible to access to data sets, so they're all free of charge when we say CDS. And you can see the atmosphere here. It's atmospheric data storage. And there are these addresses in my slide. And there could be aerosols and others. And but the gases with them, there could be some models and climate data. You can have access to all of them. I've been a bit fast, but this is all I'd like to say today. All the activities are very important, and the meteorological data is important regarding this. And all the data is there, and you can have access to them. And thank you very much for your attention. Thank you very much, Cihan Bey, for the information you provided. Now I'd like to give the floor to Levent YALCIN. I'd like to introduce Levent YALCIN. He has a Metosphere company. He is a research which is established in Gazi University. He owns the company, and he is working as a meteorologist. And of course, it's about the system and He's working in R&D in terms of photovoltaic solar energy. He has these books about this. We can start with that. I hear you. Thank you. It's been 45 years. Zeynep Hanım made a depressing but then promising presentation. They were very good visuals. And here, he made us sorry, and Cihan Bey will express about the data, how we will access the data, and also he gives the methods of this, and with the meteorologist background and with the Cenk, with the information when we gather together all this. I'll talk about the passive house, and this is the forum of this, and I'll talk about the Zero Build forum. I wanted to make a contribution to there. So I'll talk about someone who's been there, and I'd like to reiterate Yasemin Somuncu. She had made a lot of contribution, and then I'll start my presentation. When we say meteorology and climate, regarding the zero buildings, there is an address list. I will not use this one. Of course, I trust my mimics, and I think that will be important. And it is a photograph. I didn't want to have this. Of course, this is about the addresses are the building owners, then the designers, I mean the architects, and also the ones, the financiers. So these are also addresses of this, and the material production producers, and of course, the audits and the auditors there, and also so the ones who are responsible for that, the design takes 1 year. However, we are talking about the building with 60 years, and there are planners. And also in such, there are the policy makers who are making this. All of them are the addresses of the presentation here. What we would like to achieve is that we are talking about a very assertive subject, and we look at the energy efficiency, energy need, and it's about taking out the ones. And when we look at where the energy demand is here, it's about HURTT, and it covers all of this. And there is this ventilation, and I made a list, a mental list. We can involve lightning, this the energy consumer as well. Energy couldn't be only electricity energy. People think of electrical energy first, even if it is a secondary resource source. We use electricity more. We are talking about the hygiene, and of course, hygiene is there in the air quality and the microorganisms. And all of this is related to the building operation or the design of the building. When we look at the design of this person, I made an important thing in the economic resources, they are there, but in the sector, I can tell you that I'll be more critical as an approach because there are methods which are not for the ones, and also as the outside part, we have to look at the climate data and meteorological data, the current meteorological data, and it covers that. However, when we say the climate is the things and the impression with us. And of course, all the data are important for HVAC systems. We have to look at the climate data, not the meteorological data. This is not related to that, but in terms of selection of places, it is important. And when we look at the location for the place, it is important to have the climate data. When we say the direction or orientation, if we can say, we can say as this one, and it is about the whether it will be south and north, and the climate data is important. And in the other envelope, we need the data. So this is related to the when giving the direct orientation decision and the site, there is a statical and passive applications. There are the climate data, for example, the snow or wind load, and there we need passive systems and dynamic systems. And it is about the daylight, and it's about how you make use of the daylight in the most optimum manner. And there are the activities for them, and could be with natural ventilation. So you can use this, and you can use in the center. You with the increase of this passive designs, and in addition to that, the odor, for example, if there are odor present, you can want to catch them or you want to miss them. If there is a bad odor, you can. It's you couldn't do that in this one, and there could be a one, and of course you want to be there. And there are some odors, for example, there is a humidity from the sea. It's an expectation that you want, or you can use the iode and salty weather. This oxidize the metal parts, or there could be the source of smoke, for example, the lightning and this sound, for example. You want to have the take it, or you don't want to take it. For example, after the pandemic, for example, this is more important in pandemic because some microorganisms are triggered with certain air conditions, and there is a water, and there is water with precipitation, and because of the hydrological cycle, there is the subsurface water. We want to avoid it, or we want to say how, in what kind of a topography are we building our constructing our building, whether the highest precipitation will give harm to our building or not. And of course, in Ankara Gölbaşı and İzmir Metropolitan Municipality, there are the water collectors. It's about the water collection. It has become mandatory for the buildings to be licensed. So we wanted to get rid of this, or we want to avoid them, or we want to collect them, or we want to transform them by true collection of the precipitation water. And there is a lightning. So if there is such a building, of course, that you can have the building, and there could be a metal part there, and you can have the ones, and it's a passive system, and it's based on the climate data. And that could be only decided with the certain data. Of course, this is known by the sector, and everyone is saying this. I've been following the sessions for 3 months. For example, I followed the Filiz Pehlivan and Gamze's presentation in the TR45 session.
And I also asked my questions there. They showed examples from their own work as well as from around the world for zero energy buildings. But when it comes to benefiting from the climatic data, they said, of course, we benefit from it. It's very important, but I came to the actually conviction that they don't have a very well collected data. That's what I understood from their discourse. We have a discourse actually regarding the energy efficiency in the legislation. And here Article 7 refers to formative measures in the design of the buildings. Architectural and parcel should be taken into consideration. And actually the ventilation, illumination, and other needs should be kept at the maximum level. And it says the attention should be given to wind, solar energy. It says optimum, minimum, or maximum benefit. But the general idea is that, and it's one of the reasons why I chose this title. Actually, we act a little intuitively without making those calculations. Also, we see many tables, graphs, and other applications. And I looked at their backdrop. For example, a graph developed by a professor in Australia or other events developed by NGOs from the US, France, or other countries. I think that was also prepared for Ankara. However, where do we make the emphasis? We make the emphasis that the climate is changing, and I paid attention to Cihan's presentation. He says between 1980s and 2000, and he says there might be another course between 1990 and 2010, and another course between 2000 and 2020. So the trends are changing. We cannot actually use climate data as a basis as they date back to 1960s, 80s. I even took certain notes. When we talk about climate data, we can actually have an average of these long years, or maybe have a prediction between certain levels. We can make those predictions in terms of emissions. However, in engineering, we should look at the climate projections as the basis, because we are going to use these buildings not retrospectively, but towards the future. And when you introduced me, you referred to actually the books I wrote about solar energy. There's this other example, and in terms of climate change, we had certain slices. The numbers might vary, but the humidity actually decreased from 80 to 60, and then fell to 55, and then 50% in 2000, and even 45% even in 2010. So there's this 5% decrease in terms of humidity if you develop your HVAC systems, your engine power or window opening according to an analysis from 1980s, then your building will be actually not that used, become obsolete, because humidity will change and the particles in the atmosphere will actually let the sunlight permeate more, and that will even impact the photovoltaic energy financing, because you have a 5-year backdrop. Actually, you see more radiation, which means actually these lights are carried to us through photons. Electromagnetic wave actually transfers it, and it causes the globe to warm up. So there's such a recommendation in the legislation, and we understand that it is actually required. So I do not want to use the wrong word here, but we are talking about environmental conditions. What do we focus in terms of sheltering? We focus on external walls so that we get protected from outside conditions. But if we do not work as engineers, I mean, we won't be successful if you have, for example, 80 centimeter thickness, right? Then the building will not come down, right? Dear architect colleague, you should look at how to decrease it to 30 centimeter and make the most of your materials. So you may have a heating, cooling, or ventilation system design. You need to look at the pipes, the engine power, etc. of all these devices. And are you trying to, for example, decrease the value from 20 to 12, or to whether you're trying to increase 10 to 20, for example? That's what I am actually, that's why I'm actually fighting with certain terminology. For example, one of those terminologies concern type projects. I mean, we have 2,002 cities at 2,200 meters, or we have cities by the seaside and mountains, and seas actually impact the climate. You have 2,002 meter square rain for that meter in Rize, and then you have 350, for example, that value, and then you say, we have type buildings, or you have standard devices. I mean, in the centrum of Ankara, the measurements, for example, in Keçiören, has been a representative figure, but there's this area called İncek, where we have actually much structure, and here almost there are buildings with a height of 100 meters, and then we see differences of 5 to 6 centigrades. I mean, we say let's keep the global warming at 1.5 degrees, and people look down on that. But let's give this example. For example, you have a 36-degree body heat. 1 degree of increase actually makes us go to emergency services. Therefore, we should interpret that 1 to 2 Celsius degrees in the world as such. If you do designs in İncek according to what you have in Keçiören, then your pipe goes from 3.7 to 3.9. But when you do it in a 100 floor building, think about the costs or the sort of investment you need to do for the engine. And there's also the operational side of it. So I actually deny this standard or tailor-made. I believe that tailor-made designs or location-based designs should be created. And here we should look at the character and target of the building when we choose the climate data. Cihan thankfully referred to Copernic program, and there are like 300 types of data pieces generated there. Of course, some of them are related to the ocean, but let's say we have 100 different data pieces, but our architecture sector in designs or renovations, like insulation or the recladding of the buildings, actually benefit only from the heat data. That's according to what they say. There are package programs and package climate data. There is such a concept. I think meteorologists most of the meteorologist organizations are in the US, and they're very generous. They let their data be accessible, and they make global movements. And yes, they open it for Turkey, but you pick 3 destinations in Turkey: Ağrı, İzmir, Ankara. And you declare it as representing Turkey. And it's already clearly stated there. This is not about my opinion. The data shared in NASA or National Data Services, that's how they state. They can manage the global study only by giving 3 spots in Turkey. And there are certain durations there, like between 1970 and the year 2000. That's what they analyzed, and that's what they provided the statistics for. So I chose certain methods here. Of course, there are certain simulation software products, just like we simulate the air. We also use Surveyor to simulate the design or HVAC systems. That's what the H requires: Boom, Sim Up, Design Builder, Occupancy Simulator, Content, Building Energy, Asset, Restore, EPQ. There are many programs. The common point is that they provide actually these data from package climate data. That is actually very weird, and it is not actually appropriate. And here we actually graduate many valuable architects, and we do it for not just Turkey, but the entire world. And this industry takes the climate data on a monthly average. What does that mean? That's just mean checking off the checklists. I want to highlight it, and I think it should be covered by the headlines. Dear Levent, can you wrap up? Okay, thank you. For example, the softwares explain it in climate data. America actually updated these documents. WYEC, I also designed it for the typical climate data for themselves. Also, there's this degree day for cooling and heating, which is a subjective data. And they say we check the degree day values. Okay, that's great. But what is the value? I mean, how do you decide for the heating? So for example, some people say it's 22, and they shared it with the Directorate of Meteorology. Turkey, higher than 22, is worth actually cooling for 15. It's heating. Well, it is their discretion. It changes in Canada, US, and other countries, and it's a subjective value. You use these values when you design a hospital in a very unaware way, and you also use it when you design a school or even a stadium, or when you design a house, an office. It is easy to feel comfortable. That's why, and most of them are synthetic data. You just get derivatives. They do not reflect your years. You're just using the derivatives one, so that you are not bothered. That's why if our architect colleagues listen to us, I want to actually make them aware by using these phrases, you might say we will not deal with figures. We are going to proceed with conventional values. Then we should not make a claim of being an engineer or architect. I requested to deliver this speech so that I can voice these opinions. Thank you very much for giving me the opportunity. If there are any questions from our panelists or audiences, then we can talk on them. Thank you very much, Professor Levent. Now, I would like to ask this question, Ms. Zeynep. Can you hear me? Yes, I can hear you. Is it only the greenhouse gases who are responsible for the emissions for the greenhouse? Do you think there is this impact of magnetic shift on the climate change? Yes, there are such assertions, but it is not something proven. And even some scientists think that it is an exaggerated thought. These people also thought that Neanderthals were destroyed by the magnetic shift in the poles, but it is not proven. Climate Reality Project has the position of discussing greenhouse gases on climate. That's how I think as well, but it's a beautiful question. There are such claims, but I don't think that our position would change depending on that. Can I add something? In addition to Ms. Zeynep? Certain truths can be discussed within a particular period. The Earth as an existence going back to 3.7 billion years. In 3.7 billion years, you might ask the question of whether we have never experienced this heat. Yeah, that's a reasonable question. But considering that we have a 12,000-year history, starting with Göbekli Tepe, and a few centuries in modern history, then we prepared ourselves according to this heat. And that's the sort of period we are interested in. We look at the 10,000 period of humanity and then refer to risks or opportunities. Otherwise, the Earth is headed in its own direction. The question is not wrong. The answer is not wrong either, but it's like distracting. They use this discourse to say the Earth will be headed in that direction. You don't have to refer to climate change much. I have, for example, forest people as friends. They would support that the natural forest fires should not be put off, saying that's how the natural course of things actually continue. If we have that perspective, then we should not kill mosquitoes or even say that germs causing diseases can continue to survive as they are. So I do not accept that question as a legitimate one. Okay. I have a question for Mr. Levent, but can I ask it during the normal course of the discussion? Please write down in the comment section as I ask my question. I will get back to you. Mr. Levent, this type project, I started university at the age of 18 and our professors taught that there's nothing like type project. I graduated, I'm now 43 years old. I mean, that's all I know, but there's such a concept like type project. And as architects, we reject that very strongly. And NGOs also object to that, but it's like a public policy. So producing a project means a cost. I mean, that's my interpretation. On the public side, they choose the type project for that reason, and they just address the static project. Why? As it causes casualties in earthquakes. So a ventilation environment of 15 degrees should change in another location, but the projects do not pay attention to comfort as a priority. Costs comes into play. I do buildings. A building I construct in Ankara and Antalya, actually, the stone wool thickness is the same, and our money is wasted. It's a funny thing. I wanted to make this remark, and also I wanted to defend the architects with that. And there is this question: are you actually trying to give a message to the architects? Are you making a criticism? And what do you recommend? It makes actually, it is meaningful that at least a few people heard it. Well, I have such a reprieve. Of course, everyone believes that everyone tries to defend their job. And we have a 35, I have a 35-year background considering the profession and educational backgrounds. I think these things should be used as necessary. That's a right I should exercise. Also, I should defend it. When I ask it, certain architects, they say they are not aware of it at all. So if supply is a few steps ahead, it shapes demand, and vice versa. I'm on the supply side, and I should inform the demand side, saying that it is a necessity. Otherwise, that they face losses. I'm trying to teach or provide information to them. Also, I expect this very well educated people should give it a chance, give it a go. Do I have a product in my hand? No, but these areas need to be studied. Otherwise, we are going to use the synthetic data produced in the US and Canada as synthetic data for the projects we implement in Turkey. Mr. Cihan has a question. Maybe you can ask yourself. Mr. Levent's speech was very intriguing, at least for me, because it's an area I didn't know. But as I listened to it, I grasped the importance of it. I learned many things. And as I learned them, I realized that certain data become very important. Mr. Levent, thinking about the designers, companies, or architects, they want to get the most up-to-date information. They have such a demand. Where should they apply to? Is there any company, is there any institution that can provide customized information to them? Do you know of any system so that they can get hold of this information? I'm talking about accessing information or knowledge, but actually, majority of the things should be done by themselves. The information is out there. There are data, or there are explanations about the data, but they need to read and study it so that they can make it appropriate for themselves. Of course, that is appropriate. Well, let me first say this. You also told as you delivered your presentation, America is very generous about that. They moved to actually open data, and the EU has this open directive, which came into action in 2019, and ECMWF will also make their data public. I mean, actually, national meteorology organizations make these measurements and archive them using the public strength, public, and selling it back to the public institutions didn't make sense. So the US chose that path, and the EU followed them, and you are trying to adapt. You are working on your infrastructure. The Copernicus system already made their data, gigantic data available. Probably our national Directorate General of Meteorology will evolve towards that path. I mean, even if that's not the case, you can acquire data at a very favorable price. But if the pressure comes from the demand side, and there's this concept of weather business in the US, I actually started to compile hundreds of weather instances and companies working on them. Some of them are in transportation, some are in construction, some are in architecture, developing business. If they demand it as the demand side, I think the supply will develop further. I don't know which one should come first, but if the demand side requests that, then the supply can be better shaped. People doing R&D like myself, or people valuing R&D like ourselves, including professors and private sector structures that awaken, I think they can make such a request. But we are talking about $1 million projects, and please, Cenk, correct me if I'm wrong, everything from the roof to wall is built to protect from atmospheric conditions, but people are unaware of the information concerning the climates. And we have not the IoT, Internet of Things. You have automatic shutter systems, ventilation systems, water systems. When are they going to be triggered? Who will trigger them? Or according to what will they be triggered? You will say, turn on the AC after 24, but are you going to just actually push the button? I mean, you are going to have a 10,000 lira measurement station in IoT, but you don't put it there. I mean, that's how the triggers will take place. So this is actually about awareness. Hopefully this forum will contribute to that awareness. Thank you, Mr. Levent. How are we going to figure it out? How are we going to resolve it, considering the public and private sectors? We talk about energy efficiency document, and the certificates do not, buildings do not get licenses without such certificate. When the buildings are designed, they are designed according to certain regulations. Unless we have this information or meteorologically related data, including all the loads and installations in the regulations, then we are going to see meteorologists like yourself or architects as the people paying attention to that. Other people will follow their own routine. How are we going to ensure that there's this building energy performance regulation? But you have given the answer yourself. There are such educated professional people in this sector, and it can produce demands only when the regulation forces it. That's what I find as weird. I mean, we have huge doors, professional discourses, ladies and gentlemen coming to the forefront. You have engineering assertions, you have huge budgets, but when you ask, how did you calculate it? There's this free of charge data set in the US that's, I think, bothering. I think they should bother them too. It should bother them too. Thank you. Professor Zeynep, Professor Cihan, thank you very much for your contributions. This marks the end of this session. Thank you for your illuminating presentation. Would you like to add anything? As I stated, this is a life-concerning issue in zero building energy industry and every aspect of our life. We should pay attention. I'd like to thank the panel, and also I'd like to thank those who made this event happen. Mr. Cihan, 1 or 2 sentences. I thank as well. I would like to thank those who made the Zero Build conference take place. It has been a very beneficial conference full of information. Thank you very much for sharing your insights. Mr. Levent, would you like to add anything, 1 or 2 sentences? I would like to thank as well. I wish that this forum takes place for many more years, as it will bring benefits not only for our country, but for the entire humanity. Thank you very much. Would like to thank every participant for their kind attention. This marks the end of the session. Thank you.